from where we ended. We looked at vasoconstriction, platelet plug formation, and coagulation of blood. These are the 3 stages of hemostasis. So let me look at factors involved in blood clotting. Factors involved in blood clotting. Now, blood clotting is also called coagulation. Okay, and it is defined as the process in which blood loses its fluidity and becomes a jelly-like mass few minutes after it is shed out or collected in a container. It clots. It becomes a thick jelly-like substance. Now, coagulation of blood occurs through a series of reactions due to the activation of what we call clotting factors. Through the activation of clotting factors. Now, these are the clotting factors. There are about 13 of them. These clotting factors were named after the scientists who discovered them. Apart from the Christmas factor, which was named after the patient. Okay, but the other clotting factors, they were named after the scientists that discovered them. Okay, we have factor 1, which is called fibrinogen. We have factor 2, which is called prothrombin. We have factor 4, which is called calcium, and so on and so forth. Now, what are the sequence of events involved in formation of a clot? What are the sequence of events involved in the formation of a clot? In general, blood clotting occurs in 3 stages. There should be formation of a prothrombin activator. After a prothrombin activator, there should be formation of prothrombin into thrombin. And then lastly, there should be fibrinogen, which should be converted into fibrin. Now, this sequence of events requires those clotting factors. The clotting factors are actually proteins which are in form of enzymes. Now, these enzymes, they should be activated for them to convert various substances into another substances. Or in short, I may put it this way. Normally, all the factors, that is the clotting factors, are present in the form of inactive proenzymes. Okay? So these proenzymes must be activated into enzymes to enforce clot mechanism. They must be activated into enzymes to enforce clotting mechanisms. So, when one factor is activated, it will lead to activation of the second factor. And then the second factor will lead to the activation of the third factor. The third factor will lead to activation of another factor, until by the end of the day, we have a very important thrombin, which is formed, which activates a protein circulating in the blood to fibrin. Okay. And also in the formation of prothrombin activator requires activation of enzymes. Let me show you this. For example, step 1, there should be formation of prothrombin activator. This step is very important. This prothrombin activator is formed from 2 pathways. There's what you call the extrinsic pathway and the intrinsic pathway. I'll explain in a while from now. After the prothrombin activator has been formed, that's when this prothrombin can be converted into thrombin. Okay. Once we have our thrombin, it's now easy to convert the fibrinogen, which is found in circulation, produced by the liver, into fibrin monomer. Okay, so this is a fibrin which forms a cross-linked fibers on the wound, on the site of injury, therefore closing off blood loss. Okay, so as you can see, the thrombin which was formed will cause further formation of the fibrin. So if you are taught to give an example of a positive feedback mechanism, this is an example of a positive feedback mechanism. So the more the thrombin formed, the more will be the fibrin fibers formed. Okay, that is called a positive feedback mechanism. Now, let me explain the extrinsic and the intrinsic, because these two pathways, they lead to the formation of prothrombin activator. These two pathways, they lead to the formation of prothrombin activator. I'll start by looking at the intrinsic pathway. Okay, in this pathway, intrinsic meaning within the blood vessel. So this one, it is initiated by platelets which are within the blood itself. This diagram shows the intrinsic pathway. Okay, I'll start by explaining step 1. What is happening there? Blood trauma causes activation of factor 12. Okay, and the release of phospholipids. So trauma to the blood or exposure of the blood to vascular wall collagen, it alters two important clotting factors in the blood, that is factor 12. When factor 12 is disturbed, such as coming into contact with the collagen or with a wettable surface such as a glass, it takes a new molecular configuration that converts it into a proteolytic enzyme called activated factor 12. Simultaneously, the blood trauma also damages the platelets because of adherence to either collagen or wettable surface, and this releases platelet phospholipids that contains the factor 3. That is platelet factor 3, which also plays a role in subsequent clotting mechanism. Okay, so that is what's happening at stage 1. There is activation of factor 12 into, there's activation of factor 12. Now, number 2, the activation of factor 11. The activated factor 12 will act enzymatically on factor 11 to activate this factor, which is the second step in the intrinsic pathway. As you can see, this reaction requires kininogen. It requires also prekallikrein. And then step 3, activation of factor 11 by factor, or activation of factor 9 by factor 11. The activated factor 11 will then act enzymatically on factor 9 to activate this factor as well. Straightforward, that's factor 3. And then we go to step 4, activation of factor 10. What is the role of factor 8? Okay, the activated factor 9 acting in concert with factor 8, okay, with factor 8, and with the platelet phospholipids, and factor 3 from the traumatized platelets who activate factor 10. Okay, it is clear that when either factor 8 or platelets are in short supply, this step will be deficient. Okay, when factor 8 or platelets are in short supply, this step will be deficient. So factor 8 is the factor that is missing in a person with the hemophilia, for which reason this factor 8 is called antihemophilic factor. Okay, platelets are the clotting factor that are lacking in bleeding diseases called thrombocytopenia. Very important statement. Now, what is the action of factor 10. How does it form our prothrombin activator here? This is what we want. Action of activated factor 10 to form prothrombin activator requires factor 5 in the presence of calcium. Okay, so this step is the same as the last step in the extrinsic pathway. So this is the common pathway, as I'm going to explain later on. Therefore, the activated factor 10 combines with factor 5 and platelets and tissue phospholipid to form what we call prothrombin activator. So the prothrombin activator will in turn initiate the second, that is the cleavage of prothrombin into thrombin, therefore setting into motion the phytino clotting mechanism. Okay. Now, the extrinsic pathway, in this pathway, the formation of prothrombin activator is initiated by tissue thromboplastin, which is also called tissue factor, which is formed from the injured tissues. What are the sequences? The tissue factor will activate factor 7 to activate factor 7. Now, thromboplastin, which is a tissue factor, this one, it contains proteins, phospholipids, and glycoprotein. That's why it is able to activate factor 7. It's a proteolytic enzyme. Now, glycoprotein and phospholipid component of the thromboplastin will convert factor 10 into an activated form, and this requires factor 7 and also calcium. Okay, so the activated factor 10 reacts with factor 5, factor 5 and phospholipid component of tissue thromboplastin to form, this is what we want, the prothrombin activator. This reaction also requires the presence of calcium. Okay. So this is the extrinsic pathway. So I've explained how prothrombin activator is formed in both the extrinsic pathway and the intrinsic pathway. So this diagram just shows everything here. It shows everything. That is the intrinsic pathway and the extrinsic pathway. So there's an interaction. Okay. And how is the interaction? So it is clear from this diagram that the intrinsic and the extrinsic, they both take place simultaneously. Okay. And then we've said that the tissue factor, that is tissue thromboplastin, is the one that initiates the extrinsic pathway, whereas factor 12, it's the one, and the platelets, it's the one that activates the intrinsic pathway. Now, the extrinsic pathway is explosive. It takes place so fast. This one is slow. Okay, it's explosive such that it only takes place about 15 seconds. But this one can range from about 1 to 6 minutes to cause a clot. Okay. Okay, so this is how you explain the formation of prothrombin activator from extrinsic and intrinsic. That's the first step of clotting. The second step is conversion of prothrombin into thrombin. What happens?